Joseph from Making Math Easy, and today we're going to talk about naming organic molecules. So first, there's a field of science known as organic chemistry. It's the chemistry of how carbon can come together in tons and tons of combinations to form everything. There are several different notations. Here are some two-dimensional notations. You can see I've got a list of prefixes. You'll understand that later, because we're learning how to name organic molecules. Alkanes, haloalkanes, alkenes, alkynes, and alcohols, all that stuff. So, let's get started. So, what we do now, that we know, now, as you can see in this structure right here, there are 6 carbons and 14 hydrogens. And this is a covalent bond. So covalent bonds are fairly simple, C6H14. So if you learn about how to name a covalent compound, you should get that this is named hexacarbon. And then the prefix of 14, hydrogen. But that's not the case, actually. For these kinds of molecules, we have a special naming convention from a organization called the International Union of Pure and Applied Chemistry, or IUPAC. IUPAC has come up with some rules that let us determine the name of any given organic molecule given the formula. And using the names, we can give a perfectly nice structure. So let's just start with a really simple alkane. By the way, we'll be using this notation right here. This means that every endpoint and a corner is a carbon atom. And the thing is that this is what that really means. See, in a fully saturated carbon, hydrocarbons, so fully saturated are also known as alkanes, have single bonds only. No double or triple carbon bonds. Only single bonds between the carbons. Now, there can be double bonds between the carbons, and in that case, they'd be unsaturated. So they could be alkenes or alkynes if you had some pi bonds. However, and in some pi bonds, the number of hydrogens will also decrease because triple bonded, and by the way, triple bonded carbons, if they're on the edge, they can only bond to one hydrogen. So, for example, something like ethine would be drawn like this. So you have a carbon, you have carbon, and ethine, I'll get to the things how you do that later. And then you have a bond to a hydrogen atom and another bond to a hydrogen atom. And that fulfills both carbons necessarily of 4 total pairs of shared electrons. Since carbon wants 8 electrons, but a hydrogen only wants 2. So in no organic molecule will there be a double bond between a carbon and a hydrogen. And the hydrogens are not bonded to each other either. The carbons are bonded to the hydrogens, and the carbons are bonded to themselves. But the hydrogens are not bonded to anything except for the carbon they're with. Okay, so this line notation is now what we're going to use. And every time we name a molecule, we're going to base things on this. So we can learn the IUPAC rules for naming any organic molecule. At least we're going to cover a few types. So, let's say I wanted to name that 6 carbon molecule we had earlier. 1, 2, 3, 4, 5, 6. So we have 6 endpoints plus 4, 2 endpoints plus 4 vortices, so that's 6 carbons. Perfect. So we have some prefixes when naming molecules. And you might need to learn more than this many, or at least this many. You might, depending on your classroom, you might need to memorize different amounts of the prefixes. But at the very least, when learning organic chemistry, in this series, we're going to need to know all of these 10. And they are determined, the number is how many carbons in the molecule. Or, as you'll see, the number of carbons in the longest carbon chain. You'll get it. Meth, eth, prop, but, pent, hex, hept, oct, non, and dec are the basic prefixes. Though certainly there are bigger ones, like 23 is tricosa or something. Or 20 is like icosa or something. So, but we're all only going to use these 10. So, now, from the name of the general, we know, or at least IUPAC says, that the suffix of any alkane is going to be ane. So that's going to be that's what all the names of all the molecules that are fully saturated are going to end in. And now, look at how many carbons are in a molecule. 1, 2, 3, 4, 5, 6. That's hex. Add that ane to get the name hexane. But let's try another one. So, while it would be wonderful if the only 10 we needed to name were methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane, that's not going to be the case. There are some examples where you have a chemical with some substituents or other carbon chains branching off of it. When that happens, it's a bit complicated, but we can eventually handle it. So let's say you have this molecule. First of all, what you want to do is identify the longest carbon chain. Right now, by the way, this is an easy example. We are going to get more complicated, but these are some easy ones. So this is the longest carbon chain right here. And then there is a substituent, one carbon branching off of the main chain. So what we want to do is now, we know that we have 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7 carbons on this main chain. So it will end in heptane. It will end in heptane. But this does not have 7 carbons overall because there's one methyl group sticking off. So we're going to use the same prefixes, which are determined by how many carbons in the substituent, but we're going to change the suffix. Instead of an ane for the suffix of a substituent, we're going to use il. So this would be meth, and then that prefix makes it a methyl group. Okay, now we want to number the groups. So we want to number the carbons. 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. As you can see, the substituent occurs on 2 different molecules. So and that means this could have 2 molecules regardless of, depending on whether you number right to left. So IUPAC made a rule that said you need to number the carbons in such a way that this substituent occurs sooner than the other. That means that if I number this way, 1, 2, 3, 4, 5, 6, 7, it occurs on carbon 2. 1, 2, 3, 4, 5, 6, it occurs on carbon 6. So we're going to choose the lower number 1, a 2, so we're going to number this from right to left. From left to right. There. So now that we've numbered our carbons, we now need to look at where the methyl group is. It starts on carbon 2. So by the way, this will be a methyl heptane. However, right now, given this information, there are 6 possible methyl heptanes. 1, 2, 3, 4, 5, 6. By the way, it can't be on 1, 2, 3, 4, 5. Sorry, 5 possible. It It can't be on carbon 1 or carbon 7, or else you just have octane, and that wouldn't be a methylheptane. So, out of these 5 possible heptanes, which one is this one? We can identify which one it is by looking at the numbered carbon that the methyl group is on. So that numbered carbon, it's the second carbon. So you put 2 methylheptane, 2 methylheptane. So this means that we have a 2, which indicates that the methyl group occurs on the second carbon. And we don't put a space between the methyl and the heptane because for now, and we'll get more complicated eventually, but right now it's just simple, 2-methylheptane. Now, someone could read this name and draw this because it is telling you how long the longest carbon chain is, what types of substituents you have, and where the substituents occur on the molecule. So the correct name for this molecule is 2-methylheptane. Okay, let's get some more complicated in this. Let's get more complicated. So what we do now we are going to use the same rules, but we're going to do a bit more complicated. So now what we're going to do is we're going to take another alkane, let's say, so we have 1, 2, wait. Okay, so we want to identify the longest carbon chain. So 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, 4, 5, 6, 7, 8. However, this is a continuous carbon chain. This one splits up into 2, so we're going to pick this one. So, this methyl. So we have that octane derivative, 1, 2, 3, 4, 5, 6, 7, 8. And we have 2 substituents branching off from the main chain. So we're going to correctly name this. Remember to identify the longest carbon chain. Now we're going to do all the steps first so we can number from the front of the name to the back of the name. So now we want to number 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 4, 5. So we're going to number this way. By the way, it's not that when you have more than one substituent, you just say which one has any one of the substituents occurring sooner than on the other direction. So in this case, numbering left to right would do the trick. So we know that we have right here, we have a propyl group and we have another methyl group. And the propyl group, as you can see, contains 3 carbons. So what we do now is that now we need to list these, but in what order do we list them? Really, as long as you have the numbers, it doesn't matter. Anyone can still read that and draw the molecule. But just to be extra sure, so that each molecule has one and only one name, IUPAC says we must list the substituents in alphabetical order. So, what that means is we have this methyl group, but if we sing the ABCs, A, B, C, D, E, F, G, H, I, J, K, L, M, so methyl is before propyl because we haven't passed a P yet. So methyl is first. So we're going to list the methyl group first. 2-methyl, then put a hyphen, since we're listing the propyl group, for propyl. Don't do anything with the space in here, and then do octane. Again, 2-methyl-4-propyl octane can tell anyone unambiguously everything they need to know to draw this molecule. And eventually we'll get to some examples where we're given a name and we want to draw that molecule. So, what we're going to do now we're going to take one with the, so we have, so now we have that, and then so means in either direction you have a substituent occurring at the same place. Like for this one, you identify the longest carbon chain. When we number in either direction, there's a substituent occurring on carbon 4. We say that the substituent that occurs sooner alphabetically takes priority over the other one. So in this case, we have a methyl group and an ethyl group. And obviously, because you know your alphabet, E is before M, so we will number from right to left. Which gives the... Okay. So, by the way, because this ethyl group is before the methyl group, we know that we need to list it first. We have 4-ethyl plus a hyphen 6-methyl and then 9. So 4-ethyl 6-methyl 9 corresponds to this molecule, and anyone who's properly educated about how to draw molecules given the name can easily draw this molecule. Okay, so let's try another example, which is more interesting than the other ones. We're going to ignore the last rule we just talked about because there's no case that one substituent is occurring at the same place, regardless of whether we number from left to right. So you can see that we have this 1, 2, 3, 4, 5, 6, 7 derivative. So this is a heptane derivative. This is a heptane with 3 substituents, 2 methyls and 1 ethyl. So ethyl, methyl, methyl. Now, of course, you might realize that we have to number this way. First of all, however, there's a misconception, and I'm going to clear up why we don't do that in a moment. The name of this molecule is not 2-methyl 3-methyl. Oh, sorry, I forgot to number the ethyl first. It's not 4-ethyl 2-methyl 3-methyl heptane. It's not any of these derivatives. And the reason is that IUPAC says that if there's more than one of the same type, we number them simultaneously. So you can't have 2 methyls in the name. You want to have only 1 methyl. However, since there are 2 of them, we're going to use some more prefixes. 1 doesn't do anything. You don't need to put a prefix if there's only 1. However, if there are more, di is 2, tri is 3, tetra is 4, penta is 5, hexa is 6, hepta is 7, octa is 8, nona is 9, and deca is 10. We're going to keep this in mind when we name these molecules because it's going to be helpful. So keep all these prefixes at least in your mind for when we do examples in this video. Okay. So now we still have to list the ethyl group first since E before M. But now we have 2 methyls, so we list them simultaneously. But how can we list them simultaneously if we can't merge the 2 and 3 together? Because that would be 23 methyl, and that would mean this is that would mean that this has to be at least a tetracosa derivative. I know. So we don't do that. We instead put commas between the 2 numbers. 2, 3. This tells you that there is 1 on 2 and another at 3. And then it's not methyl, there are 2 of them, so we do dimethyl. However, you may be thinking, so we should have listed the methyl before the ethyl because now it's D before E. No. These prefixes, except for one that you'll see soon, are not taken into account for alphabeticity. So it remains the case that E is before M. So we still, even with the prefix, we still list the ethyl group first. So we left off with dimethyl, and then of course, since this is a heptane derivative, we ended with heptane. So now you know the basics for naming alkanes.